Hi, welcome for our discussion for today's video. I am Mary Svina and I would like to tackle the measures of relative position or quantiles for ungrouped data. For our objectives, we are to explain and demonstrate the concept of quantiles in relation to ungrouped data, including how to calculate and interpret them accurately. I hope in the end of this discussion you would learn something. Our introduction. Understanding relative position and quantiles of ungrouped data is crucial in data analysis for several reasons. Firstly, it allows us to gain a better understanding of the distribution of the data and its characteristics. So, what is measures of relative position? Measures of relative position are statistical techniques used to identify and describe the position of a specific data point within a dataset, providing insights into its relative significance. A quantile. What is quantile? Quantiles, on the other hand, are a specific type of measures of relative position to divide a dataset into equal parts or segments. They help us identify the values that represent specific percentages or proportion of the data. And group data of quantiles. As we have group data of quantiles, we also have the ungrouped data. So what is ungrouped data? For ungrouped data, quantiles are calculated by arranging the data in ascending order and then identifying specific values to divide the dataset into desired proportion. Quantiles are statistical measures that divide a dataset into equal parts, providing insights into the distribution of the data. So, here are three examples to help illustrate quantiles for ungrouped data. First is the median. The median is the most common used quantile, dividing the data into two equal parts. It represents the middle value when the data is arranged in ascending order. For example, if we have the dataset 2, 4, 6, 8, and 10, the median would be 6, as the median is the middle value of a dataset. Second, quartiles. Quartiles divide the data into four equal parts. The first quartile represents the 25th percentile, the second quartile is the median, and the third quartile represents the 75th percentile. For instance, if we have the dataset 1, 3, 5, 7, and 9, quartile 1 would be 3, quartile 2 would be 5, and quartile 3 would be 7. For percentiles, the third example, percentiles divide the data into 100 equal parts. For example, the 75th percentile represents the value below which 75% the data falls. If we have the dataset 10, 20, 30, 40, and 50, the 75th percentile would be 37.5. So here are the word problems with solutions. First problem. The heights in inches of a group of friends are as follows: 62, 64, 66, 68, and 70. Find the lower quartile, which means the first quartile or Q1. Solution and explanation. To find the lower quartile, we need to arrange the data in ascending order. As it is done, arrange. Q1 represents the value that separates lower 25% of the data. In this case, since we have 5 data points, Q1 or quartile 1 would be the median of the lower half. In this case, the lower half is 62 and 64. Therefore, quartile 1 equals parentheses of 62 plus 64 parentheses over 2 plus 63. So our answer for problem 1 is 63. Problem 2. The distances in miles traveled by a group of cyclists are as follows: 12, 15, 18, 21, and 24. Find the upper quartile, or the Q3. Solution and explanation. To find the upper quartile, we need to arrange the data in ascending order: 12, 15, 18, 21, and 24. Q3 or quartile 3 represents the value that separates the upper half, 25% of the data. In this case, since we have 5 data points, 12, 15, 18, 21, 24, quartile 3 will be the median of the upper half. In this case, the upper half is at 21 and 24. So, 21 plus 24 over 2 equals 22.5. Therefore, our answer for problem 2 is 22.5, which is the quartile 3. Let's proceed. Problem 3. The ages in years of a group of students are as follows: 18, 20, 26, 29, and 32. Find the median, or the Q2. Solution and explanation. To find the median Q2, we need to arrange the data in ascending order. 18, 20, 26, 29, and 32 are in ascending order, so we are to proceed. Q2 represents the middle value of the data. In this case, the middle value is 26. Therefore, 26 would be the median, or the answer for the problem 3. Problem 4. Determine the lower quartile of the dataset 15, 8, 14, 11, 10, 5, and 18. Solution. First, we sort the data in ascending order from 5, 8, 10, 11, 14, 15 to 19. The position of quartile 1 is 7 plus 1 over 4 is equals to 2, which corresponds to the second value in the data set. Therefore, quartile 1 is 8. Problem 5. Calculate the upper quartile, Q3 of the dataset: 27, 7, 22, 15, 10, 4, and 15. Solution. After sorting the data in ascending order, the ascending order goes like this: 4, 7, 10, 15, 22, 27, and 35. The position of quartile 3 is 3 times parentheses 7 plus 1 over 4 equals 6, which corresponds to the sixth value in the data set. Thus, Q3 or quartile 3 is 27. The answer of problem 5 is 27. So as we all done for our discussion for the measures of ungrouped data of quantiles, I would like to thank you all for watching.